Hi, I am Kavitha, Assistant Professor, Department of Mathematics. Today's topic is solving transportation problem using Vogel's approximation method. The transportation problem is the type of linear programming problem in which commodities are carved from a set of sources and a set of destinations while into account the supply and demand of the sources in order to reduce the total cost of transportation. There are two types of transportation problems, one balanced transportation problem and another one is unbalanced transportation problem. The problem is considered to be balanced transportation problem when both supplies and demands are equal. Suppose the supplies and demands are not equal, then the problem is called unbalanced transportation problem. In this situation, we add a dummy row or a dummy column is added to this type of problem depending on the necessity to make it a balanced problem. The problem can then be addressed in the same way as the balanced problem. Vogel's approximation method steps. Step 1. Identify the two lowest cost in each row and column of the given cost matrix and then write the absolute row and column difference. These differences are called penalties. Step 2. Identify the row or column with the maximum penalty and assign the corresponding cells minimum of supply and demand. If two or more columns or rows have the same maximum penalty, then we can choose one among them as per our convenience. Step 3. If the assignment in the previous satisfies the supply at the origin, delete the corresponding row. Proceed the steps again. This is the problem. Find the IBFS, initial basic feasible solution to this given problem using Vogel's approximation method. Here factories and destination centers are given, F1, F2, F3 and D1, D2, D3, D4. Supplies are 50, 60, 25. Total supply is equal to 135 and demands are 60, 40, 20, 15. Total demand is 135. Here supply and demands are equal, total supply and total demand are equal, therefore the given problem is balanced. First we take the difference between two minimum numbers in first row, that is 3, 2, difference is 1, and the second row 2, 3, difference is 1, third row F3 2, 4, difference is 2, and column we get 3, 2, 1 and 2, 5, 3 and 2, 4, 2, 3, 5, 2. Now we get the highest difference is 3. We choose the 3 in row F1, row difference, 3 is in column difference D2. We take the column D2. In D2 the smallest number is 2. We take the number 2. 2's supply and demands are 50 and 40. Therefore we take 40. 50 minus 40 is equal to 10. Cross of row D2. Again we find the differences. the reduced table. The table is D1, D3, D4 and F1, F2, F3. Minimum of first row is 3, second row is 1, third row is 2. The differences are, column differences are, first D1 first column is 1, difference 2, 3, and D3 difference is 2 and D4 difference is 2. Here the highest difference is row difference 3. We take the SL F, we take the row F1, minimum of F1 is 3, F1's demand and supply is 60, 10, minimum is 10. So we take 10 and subtract the 10 from demand and supply. We get 10 minus 10 is equal to 0, 60 minus 10 is 50. Proceed as follows. We get this final table. We cross off each and every row and column. We get the IBFS is F1 D1 is 10, F1 D2 is 40, F2 D1 is 25, F2 D5 is 20, F2 D4 is 15 and F3 D1 is 25, and that's all. The transportation cost, we multiply 3 into 10 plus 2 into 40 plus 7 into 25 plus 2 into 20 and 3 into 15 plus 2 into 25. This answer is the total transportation cost. Thank you.